Welcome and hello. This is a video tutorial on HEC HMS, and in this lesson, I'm going to talk about GIS tools. This is the second video in GIS tools, so it's part two. If you haven't already seen the part one, go ahead and check out lesson 12. That's part one. This is lesson 13, part two. All right, what I have on the map here is everything I've done up to through part one. So that's why I recommend checking that out. So here I am. I've got, let me open up the map layers. What we've done already is added a terrain, and then all these other layers have been created as we've worked our way down this GIS menu. So that's why the next option becomes enabled once we've done the previous steps, more or less. So we've created a sync fill layer, flow direction, flow accumulation, identified the streams and breakpoints. All right, the next menu item is to actually perform the delineation. So everything before this point was really pre-processing, and most everything after is post-processing. But this delineate elements method is what we're doing now, and this is where we actually delineate the watershed. Let me just go ahead and click on the flow accumulation layer, see the different stream flows within the watershed. And then, yeah, let's go to GIS, delineate elements. What it's asking for here is a prefix for the subbasins and reach names that it's going to be creating. So this process involves the whole delineation process creates subbasins and reaches, and we're going to see that pop up under our basin one here in the Watershed Explorer once the process is complete. So just to be explicit, I'm just going to be call this subbasin underscore, and then it's going to generate a number after that prefix. So for reach, I'll just say reach underscore. For insert junctions, I'm going to actually say yes to this. And what this does is this will automatically insert junctions above reaches where reaches are created in the delineate procedure. For junction, I'm also going to just go junction underscore and then convert breakpoints. I'm going to say yes, and this will convert breakpoints to computation points in the basin model, as well as convert the most downstream breakpoint to a sync element, which is the outlet to the watershed. All right, 3, 2, 1, click delineate. Okay, so right, I remember having this problem, and if you followed along with part one, you may also have this same problem. What it's telling me is that no streams were found, and that's not a problem. What we need to do instead when creating this identified stream layers, we don't actually have any identified streams here, and that's because I set the value too high. So go back up to GIS, identify streams, click continue, and instead of 100 square miles, I just put in 2 square miles, and then it reran. It generated a new layer. Now we have our primary stream based on the outlet and the flow directions. And now we're ready to perform that delineation. So let me just add in some of these layers. So GIS, delineate. Okay, I guess I have to do this again. Okay, I got those values filled in. Let's go ahead and click delineate. And now we have a progress bar. Okay, so here we have our delineation. We also have a bunch of new layers here. So we have a discretization layer, subbasins, 2D connection, reaches, and icons. Those were all added, and as well as a lot of icons on the map, but they're not layers per se. What they are is the subbasins and reaches that now populate inside of our basin. So that junction, reach, and subbasin prefixes that we specified, those are showing up here with a number. And again, this is hydrologically ordered. So the outlet, which would be at the bottom, is sync 1. And that's down here at our outlet point. And then it works up hydrologically from there. So I've zoomed out a little bit. Now you can see the subbasins, the reaches, and the different junction points on the map. One thing I've noticed is that the watershed appears to cut off in this vertical line here, north-south line, but that's not really true. That's just because I did not include the next terrain file over to the east. So if you see, I toggled on the terrain file, and you can see that the rectangle just stops here. So obviously that would not be good for a real world situation, and I would need to include more terrain to include the full watershed. But what I have here is what I'm going to work with in this tutorial. Okay, I've turned off the terrain layer, and I'm going to zoom in on an area over here. Next, I'm going to demonstrate the next couple options here, split elements and merge elements. Now, before I can split or merge, I need to have performed the delineation, and then I need to select a reach or a sub-basin to split. Let's go with sub-basin 145. I'm going to go, it's selected. Now I'm going to go and click split element. And then it's asked, now I need to select where in this sub-basin to split. So I'll just select here for whatever reason. Do you wish to accept the element split resulting from the selected point, which is right here? So I'll say accept. And then let's see, it looks like it zoomed me out. So let's try to find that sub-basin again. Okay, here it is. Now we have two basins. There's sub-basin 1 and sub-basin 2. It's named a little bit differently because it's a capital S and it's a dash instead of a lowercase s and a underscore. And then we have sub-basin 1 with a reach to the outlet, sub-basin 2 linked to that same outlet. All right, so we can do the same thing with a reach. So for instance, if I wanted to split a reach, I would select the reach like here, and then go to GIS, split element, and then I believe I just click on the reach somewhere, and then could not split the element because the split point did not intersect the element. Okay, so I guess I just missed. Let me try that again. Let's try that again. I've zoomed in much further. I'm selecting the element, and then I'm going to go GIS, split element, make sure I'm on the reach this time when I click. Sure. Okay, so it looks like I got it. Do I want to accept the changes? Yes. And let's zoom in to find that reach split. Okay, here it is. If you can see it, we now have reach 1, and downstream of that is reach 2. Now I'm going to zoom out and demonstrate the merge. So for instance, if I wanted to merge these two subbasins, I would select them both. I'll hold down. Yeah, okay. I have to hold down Control and left click to select multiple subbasins. Then I'll go GIS, and because multiple elements, subbasins, or reaches are selected, I can now select Merge Elements, and it did that automatically for me. Now I'm going to zoom in and notice that this subbasin 3 is the resulting merged basin from what we just did. You can also merge reaches by clicking multiple reaches and so on. One rule about merging is that the elements must be adjacent and share a common outlet point to be merged. So in the case of subbasin that I just merged, that was true. It's also up to the modeler to use some intuition as to what subbasins should be merged, because HMS will do the work and check for adjacent boundaries and shared outlets, but it won't necessarily make the best engineering decisions. That's up to the human. The next tool on the GIS list is to reverse the flow direction. So what I would do in that situation is select the reach. This particular option is grayed out for me because there's no reason to reverse the flow direction here. It's already connected and it's already flowing in the correct direction. But this option does exist because it allows the user to reverse the flow direction, swap the upstream and downstream ends of the reach in the event that the reach was imported incorrectly from the source data. This reverse flow direction tool is typically used in cases where imported elements flow in the incorrect direction, and it affects any elements that flow downstream into that reach. The last few steps I'm going to talk about in groups. So the georeference existing elements and import georeferenced elements work pretty much the same. I'm not going to perform these actions, but I'm going to explain how they work. So if I go ahead and select georeference existing elements, there's a 3-step wizard that you're expected to complete here. The first step asks you to identify the element type. So you'd select either the subbasin or the reaches. So we'll just select the subbasin. Then click Next. The next step here asks you to find the GIS file. Now it's looking for a shapefile, so go ahead and navigate to that shapefile, select it, and then click Select Button. And then click Next. Now the last step here, 3 of 3, it asks you to identify the name of the hydrologic element. So once you select the shapefile, it will read that shapefile's metadata, and then the list of names here will appear in this list box. So that refers to the value in the name field of the DBF file. So you'll go ahead and select that and then click Finish. Now I got a warning because I didn't select the shapefile, but it would load up those elements that you selected into your map. So whether you're referencing existing elements or importing new elements, that's how that works. The next item down in the GIS menu is export layers. So of course, this whole time we've noticed that our layer map is increasing as we perform these different delineation tools and processes. And now it's our opportunity to export some of these layers, such as the subbasins. Let's go ahead and do that. GIS, export layers. Now we can select from the basins, the reaches, the junctions. Let's go ahead and select subbasins. And this is step 1 of 2. So we click next. Now it's asking for us to define the file path of the shapefile that this process will generate. So I'm going to click the folder, navigate to my main project directory. That's fine. And then I'm just going to call this subbasins underscore export dot shp. Or I'll leave the file extension off, but I'm pretty sure it's a shapefile. Okay, I'll go ahead and click save and then finish. Let that process run. So I've navigated to that folder, and here are the files. It actually created 4 separate files. Here's the shape file. So anyway, long story short, these are shape files that we just exported and can be imported into another GIS type of mapping system, because these exported features are in the Esri shapefile format. All right, back to HMS. Let's go to compute grid cells. So what I need to do here first is actually select a subbasin, as I've done here, subbasin 3. And then I'm going to go down to the components editor. So I've got subbasins 3 selected in the Watershed Explorer. And the discretization method is set to none by default, but let's go ahead and change that to structured and then click yes because I'm sure. And now let's go compute grid cells. Okay, I'm not seeing it on the map yet. That's just because I need to turn that grid cells layer on and then turn on the discretization layer. Okay, there it is. And I think yeah, okay. So now we see the grid cells inside this particular layer, and the cell size is probably a little bit too large. Let's go to a neighboring subbasin and do the same thing, but with a smaller cell size. So let's go up to subbasin 172 here. I'm selecting it. And then over here, let's change discretization method to structured. Okay. And now in this discretization sub tab, I'm going to change the cell size from 2000 to 1000. Click save. And now let's go ahead and perform that grid cell operation. All right, as you see, the resulting grid cell shows cell sizes that are half the size side length as the previous, which is exactly what we want. Grids in HMS are important because it's how we define precipitation, and then based on the particular subbasin method, that precipitation is generated into runoff, which is the whole point of subbasins. I'll discuss more in a future lesson regarding subbasin elements on this topic. All right, the very last tool here in GIS is compute and create grid cell files. So if we go ahead and do that, we can select the projection and the cell size. Let's go ahead and make it a smaller cell size, and I'll show you why I want to do it this way. And then click next. And now we have to specify the path. So let's just call it basin1.mod. That's fine. I'll click finish. Now I'm going to find that file. Here it is, basin1.mod. And then I'm going to open up this file here. And what we're seeing is for each subbasin, here's subbasin 12, here's subbasin 11, and so on, we're seeing the different data for grid cells. So what we're seeing is X coordinate, Y coordinate, and then travel length and area. Based on my selection of the cell size, 0.25, I can tell right now is the maximum cell size, and that means that this cell is completely inside the subbasin. And same with this one and this one, but most of these cells are not inside the subbasin, which may lead me to want to perform this operation again using smaller cell sizes. The travel length is computed using the flow direction grid. A grid cell file like we just created can be used to apply gridded precipitation to a basin model, or when using any of the gridded methods in the meteorological model. So that's it for part 2 and the completion of this GIS menu. What we did was in part 1, we added a terrain file to a basin, did some pre-processing, and then now in part 2, we performed the delineation and some of the post-processing tools used here in this menu.